In this video, we will be using Voyager 1 and Voyager 2 trajectory data to demonstrate how to create interplanetary trajectory scenes with Cosmographia. As always, we've added a new scene directory in the GitHub repository, except we did not include the Voyager's BSP kernels here due to their file size, but we'll be putting a link in the description where you can get them on the NAIF website. And here is the brief output for those two kernels. So if we go Voyager star, we have both of those kernels, and we see Voyager 1 has a SPICE ID of -31 and Voyager 2 of -32, and these are the start dates for their trajectory data. The bash, the load, and the SPICE catalogs are all the same as usual. And for the spacecraft catalog, we want to make sure that we have the sun set as the center of the trajectories this time, and the duration of the trajectory plot set to a much longer time, like 30 years in this case, to keep them from fading away. And you could also just as well turn the fade to 0 to keep them from fading away. For the Python script, we have all the usuals at the top. We get the initial camera position and orientation from the parse Cosmo URL procedure, but the sequence here takes a bit of trial and error. So the first thing for the time rate, we can experiment here manually by seeing what works for the length of the scene that you're looking for. So maybe 30 seconds or something like that. So if we go to time, we go to time, and then we can just experiment, say what happens if we do 100,000 time, and that obviously doesn't really look like anything in this case. So then if we do 1,000,000 time, we do see a bit of movement there. And then we can see maybe 10 million would be the right move for the initial part of the scene. Once we have that time rate down, we can just take a guess at how long we want to wait at that time rate for, say, the Voyager spacecraft to reach Jupiter. And then we're going to dolly backward. And this, again, looks like a very arbitrary number because it is. And that's just exactly the same as the Z component of the initial camera position. So we're just saying go to twice that value. So maybe scoot out about this much. So then you can see to Saturn. And then do that for 5 seconds. And then after 5 seconds, the Voyagers will have reached Saturn, and again, dolly backward. This is the exact same number, but with a 4 at the front because we need a bit more space to get all the way out to Neptune. And we do that, and after that's done, again, these 5 seconds are also just trial and error experimenting to see what works. Then we're going to speed up the time rate to 300 million instead of that 100 million. And then this Cosmos circle center down is just that if we want to see the inclination changes of the Voyager spacecraft, we can do that. Because they're pretty interesting, and then just waiting till the end after speeding up a little bit more. So that's it for this video, and it was a quick one because those interplanetary scenes are some of the most straightforward ones to make. And in the next video, we'll get into rotating reference frames like the Earth-Moon rotating frame, and we'll be using the proposed Orion near rectilinear halo orbit as an example, as well as demonstrating how to create reference frame SPICE kernels.